Mustafa Tan, and Product Manager at Prota Software. I have been working in Prota for nearly 20 years. I'm a civil engineer myself with a master's degree on structural engineering and earthquake engineering. Okay. So the focus of ProtaStructure 2025 was especially the code support. What we did in this sense was we implemented the ACI, Eurocodes, and AISC seismic checks and other checks with detailed reports, especially reinforced concrete beam and column and shear wall checks. For Eurocode, we are still working to put more clauses, but we have detailed reports that will give you step-by-step calculations and code references. And also, we developed new design automation. For example, in fact, in the previous version, we brought you composite slabs, and in 2025, we improved the combination system, and we brought you the ULS and SLS combinations for steel and concrete in separate groups. I will show you this with a live demonstration. And also in terms of earthquake engineering, we have developed multi-mode pushover analysis in this version, and especially for special structures with large span beams, large cantilever columns, or slanting columns, you can now calculate the vertical earthquake effect with the Modal vertical earthquake analysis. And also we have new tools like space truss, castellated beams, and we improved the modeling in the 3D environment with new copy and move commands, especially copy special or match properties commands. And in terms of beam integration, we have now better IFC support. Especially now we have IFC 4 support, version 4. And IFC version 4, of course, is more capable in collaboration, so we now support that. And also, we can now, most importantly, we can now export the steel connections to Ideastatica. In terms of analysis post-processing, we can visualize the nonlinear analysis results. What I mean with that, you can now see the plastic hinge formation, you can see the earthquake animation, and also you have now more control over the analytical model by filtering the selected parts. And also we have seismic detailing improvements features, and also we have new features in ProtaSteel with new connection macros, again the Ideastatica exports, etc. So, as I said, I will be doing a live demonstration, so I'll just close the presentation for now and open ProtaStructure. Okay. First of all, as you know, ProtaStructure supports international design codes, concrete design codes, steel design codes, composites, loading codes, wind codes, and earthquake codes in a detailed manner. So you can select among a large list of combination codes, design codes, and seismic codes here. And also, ProtaStructure supports a template system. So when you start your project, you can start with a country template, for example, Macedonia template, or Colombia, Malaysia, Peru. And all these templates, in fact, collects all the settings and all the best practices that is required for that area. So you don't have to deal with any detailed settings in order to kickstart your project. Of course, you can customize, and you can also save your favorite settings as a new template, but these are provided out of the box for you. And here in this project, we are working with the ACI 2019. and Columbia code as an example, for earthquake code. So when you look at the seismic parameters in ProtaStructure, the seismic, especially the seismic parameters, are quite parametric. So when you open the seismic dialog, you will see all the parameters that are inside the code, especially the cities. And for example, a city may be located in a specific earthquake zone, so they are already inside the software. So you can, by looking at the helper tables and the pictures, or by selecting the necessary parameters, you can fill up the structural options here, the parameters that are applicable to your structure, and elastic spectrum and design spectrum will be automatically calculated. For example, you may have a moment resisting frame with special ductility, so the basic behavior factor or the overstrength factor will be automatically fetched from the code and incorporated in the project. Of course, basic behavior factor, overstrength factor, or factors like lack of redundancy or any other factor are customizable further. And we also have here the analysis options like application of accidental eccentricity, damping ratio, number of horizontal modes or number of vertical modes. You can even use user-defined periods in equivalent static analysis. So ProtaStructure automatically performs an eigenvalue analysis to calculate the vibration periods. But if you want to use your own calculated values, you can enter them here as well. So ProtaStructure in that case will not use the results from eigenvalue analysis, of course, for equivalent static analysis. So the seismic design and seismic analysis doesn't finish with the base shear calculation. After that, you have to evaluate or assess the irregularities in the structure. For example, for American codes, we have a extreme torsional irregularity, reentrant corners, diaphragm discontinuity, etc. So in plan and in elevation. So ProtaStructure will automatically determine the torsional, extreme torsional, or weak story, soft story, or non-uniform mass distribution. Diaphragm discontinuity is not automatically detected, but you have all the tools for diaphragm consideration. ProtaStructure will understand the multiple diaphragm or flexible diaphragm. So you can use all the modeling tools, all the diaphragm tools to cater for any diaphragm discontinuity. For example, if you believe that you have a diaphragm discontinuity in your structure, what you will do, you will just, in the analysis model options, you will just play with or fine-tune the Storey diaphragm model. You can force and the whole floor, entire floor, to act as a single diaphragm, or you can make ProtaStructure to decide the diaphragm options for you. So ProtaStructure will look at the slabs touching each other. So if they are apart from each other, ProtaStructure will model the separate diaphragms. If there are no slabs, then it will, all the nodes on that Storey level will be free nodes. Or if you can, if you want to consider a flexible diaphragm, you can just assume there are no rigid diaphragms at those levels. But in that case, if you want to consider the flexible diaphragm, you have to mesh the floors here. Anyway, this is a bit much detail, but you have all the tools to review the regularities and the diaphragm options in the structure. And of course, I will talk about the combination system, but also in ProtaStructure we have a very flexible combination system with loading generator. And for seismic analysis, you can select equivalent loads or modal response spectrum approach. And also for vertical earthquake, you can you can select static approach or modal approach as well. Anyway, I will be talking this in much detail. But one thing we did in the new version is the strength reduction factors. If you are using the US codes, each version, each iteration of US codes may require different strength reduction factors. So you can now customize this in ProtaStructure and incorporate different variations of the US codes, especially ACI codes, in practice. Another important thing we did in ProtaStructure, as I said, now for columns and walls, of course, you can now, let's see the report. You will now see a detailed report on, we already have the detailed report on the flexural design and shear design, but now we have a detailed section on shear design. So if an earthquake code is selected, you will be seeing these details of the shear design step by step, with step-by-step formulas and the code references here. So for example, concrete shear contribution. In US codes, you have to satisfy two conditions, for example, and the software now showing you the conditions here, for example. And you have all the details here at your disposal, and you can check those with the detailed report. So this is new actually in ProtaStructure 2025. So in the previous versions, we didn't have these shear design details in the columns, in the shear walls, and in the beams. So when you design a column against the shear, against the earthquake, of course you have, especially if the column is a ductile column or frame, I mean, moment resisting frame, there are two important checks you have to do, which one of which is the joint shear check. While you are designing the column, you can also take a look at the joint shear and the strong column check as well. And we have the same thing for Storey beams, for example. Let's see. Now let's see detailed reports. And in the detailed report, you will now be seeing the seismic checks. These are also new in ProtaStructure. So depending on the ductility level of the member of the structure, you will be seeing a lot of extra seismic checks here for the shear, for the reinforced concrete beams. Oh, sorry. And also what we did for US codes especially. So when you have a long span beam, you can now check the deflection and crack checks here. So these detailed deflection checks, long-term deflection checks, are now adapted to according to ACI codes, Indian codes, Colombian and other codes as well. So, but these things we are currently working for Eurocode as well. In ProtaStructure 2025, the long-term deflection checks for Eurocodes is not available right now, but we are working on it, and we will be implementing that in the next major version. So for ACI, you will now have a detailed deflection check, which basically calculates an effective section property by checking the supports and the span separately, by deciding if they are correct or not. Will calculate the final deflection And also if you have user-defined serviceability combinations, those combinations will also be checked here as well. So this is also new in ProtaStructure. Okay, let's continue. Okay, let's check this model. This is a sample project that I created that includes all the adverse structural members, structural configurations, like a very long span beam, a large cantilever here, a transfer beam supporting a column, a large span waffle slab, gallery openings, slanting columns, etc. So this is a very typical example for a detailed vertical earthquake calculation. So according to most of the seismic codes, when you encounter such a structure, you have to, or one of the configurations in a structure, you have to resort to a modal earthquake analysis. So how we do that? In the loading section, in the loading generator, all you have to say is, I want to add the vertical seismic cases in my project, and I want to apply the modal spectrum analysis method. So in that case, ProtaStructure will perform a vertical mode superposition analysis in the vertical direction. And also, if you check the combinations, all the vertical earthquake cases will be properly added to the combinations. For example, if you say edit, you will see that the vertical case is added with a 0.3 factor as well. And the other aspects, of course, if you perform a modal earthquake analysis, that means you will need a vertical spectrum. So in the spectrum interface, you have direction 1, lateral, direction 2, horizontal, these two, direction 1 and 2, and vertical spectrum definitions. This will be calculated by ProtaStructure again. By, of course, if the seismic code has the vertical spectrum definition, ProtaStructure will incorporate it here. And also in the analysis part, you have to specify number of vertical modes. Anyway, so after you perform the analysis, you can check the analysis model. Let's see, okay. So this is the analysis model created for this project. First things first, we can just look at the mode shapes. Let's animate this. Maybe we can exaggerate the animation scale, like 8. Okay, see, in the first mode, only the large span, the waffle slab is vibrating very dominantly. And the second mode, the second floor is vibrating, but the top floor is vibrating in a different manner. So let's check the mode 3. So now another slab comes into the play. And depending on the participation, the separate vibration modes in vertical direction, you will be seeing. Okay, so what we do actually, when we check the EZ load case, so now EZ load case is the combination of these mode shapes, of course, with their multiplied with their modal participations. So as a result of these different vertical vibrations, we will be calculating a vertical earthquake effect. So let's stop this. So if we check, for example, let's get rid of the labels as well, and maybe displacements. Let's check moments. So as you see, we have moments on the members, but we cannot be sure about the sign, because as you see, there is a lot of different vibrations in the system. So maybe one of the beams having hogging moment, another beam maybe having a sagging moment at the same time with different signs. So you cannot, especially in mode superposition analysis, you cannot be 100% sure about the sign of the members. Of course, the signs are lost actually as a result of CQC analysis. So what we do here, we bring back the signs by looking at the dominant mode, vibration mode. Anyway, let's check the axial loads. Especially, I would expect some axial loads in the slanting columns. So yes, we have. But in order to calculate these effects, of course, in order to calculate these effects, we have to calculate the vertical masses. So as you see, at each joint, we have calculated the vertical mass mz. So mx and my are required for the lateral analysis, but mz is important because you always have to have some mz mass regardless of the horizontal analysis. And also, if you want to capture the correct behavior, you have to mesh the slab to get the vibration modes properly. Let's see. And also for the also for the waffle slab at the intersection of the ribs, we calculate the vertical masses as well. Okay, so this is pretty much what we do in the Modal vertical earthquake analysis. So it's a very detailed, sophisticated vibration analysis, actually. Okay. Similar to reinforced concrete members, in this version, we also concentrated on the steel members as well. But I have to say that the ProtaStructure 2025 version was mostly about the US code. So we concentrated our efforts in US code support. So we were supporting, of course, the US codes, especially ACI implementation and the other similar codes implementation, like Philippines, Indonesia, Colombia, Peru. These are all very similar to ACI codes. Their design codes are very similar to ACI code, but in ProtaStructure 2025, we concentrated on especially the chapter 18 of ACI, the seismic design part, reinforced concrete seismic design part of ACI. That was the main focus. Of course, we did, and also AISC 341 for steel members. So that means what I'll show you right now is the seismic checks on the steel members. That was the main focus of ProtaStructure. Of course, we implemented some Eurocode clauses as well. I will talk about them, but the major Eurocode 8 support, design support, will be coming with the next version. So that's I want to especially emphasize here. But that doesn't mean that ProtaStructure 2025 doesn't have any seismic support for Eurocode 8 at the moment. So let's concentrate on the steel checks here. For example, for this member, for steel member design, you will see now the seismic checks portion here. Okay, especially if you have an eccentric brace, those eccentric brace checks will be done. The plastic region, those checks will be automatically done here as well. And also, the most important check in steel is about the section classification. So we have to use the compact sections for designing against earthquakes. So those checks are also done in ProtaStructure now. Okay. So since we talk about Eurocode, in ProtaStructure, of course, we have the Eurocode 8 support. We can calculate the base shear according to Eurocode 8, and we can perform the irregularity checks. We can do the basic design according to Eurocode. So we have all the tools actually for Eurocode 8, but we will be bringing more and more clauses for the design in the next major version. So what we have actually in ProtaStructure 2024 actually the previous version, you can now use two different behavior factors for Eurocode as well. So in one direction, if you have a braced frame, or in another direction, if you have a moment resisting frame, you can now use different behavior factors in Eurocode. And also in this version, we have developed the shear wall moment and shear envelope. In Eurocode terms, it's called the tension shift. So we calculate the tension shift, and we use the envelope moments at the critical height in order to ensure the ductile behavior, ductile design of the shear wall. And also we calculate the shear envelope as well. Okay, this was the two items that I wanted to mention before going any further. And also, one important feature that's worth mentioning. In fact, again, this was developed with the previous version, but we have done a lot of improvements in this version as well for the composite slabs. So, first of all, we developed the frame member, which is a member independent of the axis definitions. So these can be freely defined, freely inserted anywhere on the model. So you have now the steel beam, primary composite beam, secondary composite beam. You can insert a frame as a girth frame, a purlin frame, a horizontal brace frame, vertical brace frame, or a frame group. Especially when it comes to the composite slabs, it's important to insert the frames in a single click. So that's what we did. So we have a frame group member here. What we do, we just select the type, like secondary composite beam. We are in, maybe I should switch to Storey 1, and again the frame group here. So secondary composite, you can select a section for that group, and also select the insertion methods. All you have to do is click on closed region. Okay, and if you rotate, you can insert it in the other direction. So it's actually parametric. So you can say I have 8 beams here. So all the layout is automatically changed. You don't have to do any extra operation. So these are the frame groups. Now I have to insert the composite slab by using 2 points. For composite slabs, I have 2 options. First of all, the direction will be 90 degrees. Okay. I can say that the composite slab is sitting on top of the primary beams, or they are leveled with the primary beam flange. So I will say that it will be above the flange, so that primary beams are also acting as composite beams. What you have to do is set the slab thickness, the concrete thickness. You can select the deck type. We have a library for sheetings. You can also select a mesh reinforcement for the topping. So that mesh reinforcement will be used in the design. The self-weight will be automatically calculated, but if you have other loads like construction stage loads, so this is important because we cannot just get away with composite design with a single analysis, because in composite design we have to consider the construction stage without concrete, or even worse, when the concrete is wet, not set yet. So during the construction stage, the weight of the concrete will be considered as a live load, and also on top of that, maybe we have other extra live loads like workers, equipment, machinery. So we have to consider this as a construction stage live load as well. And for dead loads, you can select from the library or just type in any value. And also for the final composite stage, you can select any live load value. So these are the things that you have to enter for defining the composite slab. Of course, all the effective widths are calculated automatically. So effective widths are important because these effective widths will be used to calculate the composite section properties, transformed section properties. And also all the loads will be decomposed onto the secondary beams automatically as well. So let's say OK. And also let's insert the second one here. The angle will be 0 degrees. Let's say OK. So the first floor composite slabs are ready. Now I want to generate them to the other story. Sorry, let's do this. If you have a large selection set, you can narrow it down actually. Let me show it to you as well. So maybe I want to focus to story 1. I want to select the frame groups and the composite slabs, and the selection set is narrowed down to these members only. And I want to generate them to other story 2 and story 3. And OK. Now I'm done. OK, but as you see here, there's a one important detail here. So this slab, this concrete slab, composite slab, pushed down both the secondary frames and the composite primary composite frame, because we always want this concrete slab to be flush, to be on the story level. So that's why by the slab thickness, this composite frame, primary composite frame, was pushed down by -12 centimeters. It's a constructive offset. It's not an analytical offset. Okay, this is one important detail. So ProtaStructure will always try to stick to the physical locations for proper physical locations for seamless fabrication and seamless detailed drawings. So let's do the analysis. And also, when you look at the building analysis model, you will see the entire model analyzed with the composite properties. Okay. Sorry for the inconvenience. I don't know why the sound is cutting off. Anyway, so this is the analysis model and the workflow for the composite design. So of course, it doesn't stop with the analysis. In the design part, we have composite beam design. Let's see. Okay. For example, the secondary beam. Let's see why it is failing. It's failing because of the construction stage bending check. Let's check another one. This one, okay. So this is okay. ProtaStructure can calculate the shear stats, a single layout or a double layout manner. And also you can use segmented stats or uniform stats. Segmented stats especially are useful when the beam is carrying some point loads and the moment gradient is too high. So sometimes segmented layout will give more economical results in those situations, but usually the uniform layout is used. And also we have a detailed report here also, a detailed report on composite design. You will see all the aspects of the design here, which I will not go into the details. But one important thing maybe worth mentioning is the composite degree. So when you start the designing, of course, we don't assume a full composite behavior between the concrete and the steel. So if we assume the 100% composite ratio, that will require a lot of a huge number of stats. So in order to balance between the economy and safety, we assume a composite degree. That's not something we invented, but that's the way it is when you do the composite design. So you can fine-tune the composite ratio, the composite degree for each of the beam. You can control it member by member, or let's check the composite design settings. And also you can also at the beginning you can set the composite analysis composite degree so that all the member properties, composite member properties, are calculated by using this analysis composite degree. That's also possible. If you change this, you have to repeat the analysis because the section properties will change. And also I forgot to mention that we have a large library for shear stats as well. We have other settings here, like the camber considerations, stud placement, clearance, etc. And also one important thing that if you will be propping the floors when you are constructing, you can omit the construction stage checks. So if the composite slabs are propped, you can just ignore the construction stage changes. Okay, and this was pretty much what I wanted to talk about the composite slabs. Let's move on with the other topic, which is a special way of putting reinforcements on the in flat slabs and mat foundations. So this is again a very important addition in ProtaStructure. Say we have a flat slab here. So if we update the steel bar, you will see that this finite element strip, slab strip, has calculated number 16 bars with 200 millimeter spacing. Okay, let's not forget this. And also let's check the analysis results. Let's get rid of the displacements here. And if you check the moment profile of the slab, you see the station points that this finite element strip is collecting results. So from these small dots, we are collecting the results and making it ready for the reinforcement calculation. Okay, so in the tributary area from these stations, number 16 bars are calculated at the top. But and also what we can do, you can open up the top reinforcement contours on the plan view as I did here, so you can see the model and the finite element contours at the same time. But I'm not happy about this layout. I want to change it, so I want to use less reinforcement, a fixed reinforcement. and I want to use additional bars at the column regions. For this purpose, what I want to do is I want to insert drop panel. I mean, not drop panel, sorry, patch zone. A patch zone or a patch region is a fictitious region. It's a mathematical or imaginary region that you can calculate additional reinforcement. It's not something physical. So let's say 3000 by 3000. Okay. Now ProtaStructure will intelligently crop the patch region at the corners of the plan view. Anyway, so let's delete the steel bars and check the analysis model once more. So now you can see there's a slight difference in this station points. The patch region points are shown with a dark green color. That means this slab strip is not collecting any result from these dark points. The slab strip is only collecting results from the region outside the patch regions. Because that makes sense, because we want to calculate base reinforcements, a fixed reinforcement, except the patch areas. And in the patch areas, we want to calculate the additional reinforcements. So let's see the slab strip profile. For example, for the vertical loads, this is the, this also maybe, so you see the moment values. For example, let's concentrate on the MD, which includes the wood armor effects. So we calculate minus 51, minus 52 at the top when we ignore the patch regions. Currently, it ignores the patch regions. So when I say don't ignore the patch regions, the result will be 116. So instead of 116, now this strip will calculate the base reinforcement, the fixed reinforcement, with 52. Okay. Let's go back to plan view. Now I want to update the steel bars. Now, as you see, the base reinforcement dropped to number 10 at 200 millimeter spacing. And at the patch regions, we now started to calculate number 12 bars. So this is a way of calculating the additional top bars in the flat slabs. And if you are designing a mat foundations, we will start to calculate the additional bottom bars. And also you can see that in the slab design, when you double click, you see that the FE strip itself is calculating H10, number 10 bars. You can, of course, change these bars as well here. You can control it. Let's say drop it to number 8. Now the design is not sufficient, obviously. Now increase it to 10 again. And also the patch region design is also can be seen here. You can also control the patch region reinforcements here. And also if you get a report, you will get in a tabulated manner. Okay. So far, so good. Let's continue with another project. Now what I want to do is I want to talk about the load combination system a bit. Okay, I think this can be a good project for it. So any questions up to now? Is everything fine? I don't know if you're asking questions because we have the team on board. They are following the chat box. Actually, you can ask your questions. Our support team is ready for your questions. You can ask anytime. Okay, let's see. Okay, the combination system in ProtaStructure is actually quite flexible. So what we did with this version, maybe, yeah, okay, this is fine. In this version, what we did, we redesigned the combination interface so that it is now much more user-friendly. You, instead of the old large matrix style combinations, you will now be seeing the combinations in a color-coded manner. You can understand the load cases and the combination signs and combination factors very clearly from the new interface. And also we developed, we brought you the 4 different combination groups. Ultimate limit states for concrete, ultimate limit state for steel members, serviceability limit state combinations for reinforced concrete, and serviceability limit states combinations for steel members. So we have now 4 different groups. In the previous version, all the SLS combinations were considered under the hood by ProtaStructure while you are doing the design. So you weren't able to customize the SLS combinations in the previous versions, but now you can. So I'll show you how you can do it. And also, we have a better loading generator. In the previous version, as you know, in the loading generator, you can set options like I don't want the pattern loads, I want the stage cases, I want thermal loads, maybe I can use a seismic loading, etc., notional loading. So in this loading editor, it's just like a wizard, and you can set the options, and by looking at those options, ProtaStructure will create a combination set automatically for you, but of course looking at the design code. And previously, these options were not remembered. When you exit the loading generator, all the options were forgotten, and you had to select from the beginning again. You don't have to do it here. All the options will be remembered in this version. Anyway, so I also talked about the SLS and ULS. So the steel members will only use these 4 combinations, and RC members will only use these 3 combinations, and the serviceability checks will be done for these combinations only. We will improve this further more. So what I want to do here is I want to add additional load cases. This is actually, again, one of the new features, one of the strong features in ProtaStructure. You can define as many user-defined vertical loads or lateral loads as possible. So I have a user-defined vertical load. I want this vertical load to be considered in the Storey mass calculations. Okay, and I will add another one with Q1. And this is a vertical load again, user-defined, and it's a live load case. Okay, that's done. And what I want to do, I want to create 2 more serviceability combinations for steel. So let's say G1 plus 0.5 Q1. Okay, and double click. Let's get rid of this coefficient, and 1 and 0.5 here. Okay, now you have 1 combination. And another one maybe is the only Q1. Sorry. Okay, let's zero this out and put 1 here. So this combination, SLS combination, is only comprised of the new Q1 loads. Let's say okay. What I want to do now, maybe in this girth frame, I want to apply loads. Okay, with the load editor, I now have this number in front of me, and I select the G1 here. Maybe I have a full uniform load in gravity direction. Okay, 1 kilonewton per meter, and done. The Q1, instead of a uniform load, I will have function loads. Let's say I want to use the loaded generator here, something like this. Maybe it's 0.5, 10% from the beginning, 10%, let's say 80%. Okay. You can always select a load and edit further. Maybe I can make it 60% and update it. So you can always change the profile any way you like. It's up to you. And say, okay, now I have two loads defined on this number. And let's do the analysis. Okay. Let's quickly check the analytical model. So I want to show you the some maybe features here. So let's switch to the V1 load case and open the frame load. You see my frame load, uniform load here is sitting on top of this one in V1 load case. And in the Q1 load case, I have another uniformly distributed loads. And in the analysis post-processor, actually, we have some improvements. So maybe I can mention about those a little bit. Maybe I can show it to you in another model. Let's close it for now and concentrate on what we have. Okay, so when I check the steel member design, okay, you will now see the deflection part. I have G1 plus 0.5 Q1 and Q1. Additional SLS combinations will also appear here, and the deflections will be checked according to these new combinations as well. So that's what I wanted to show you. Okay. All right. What we did in ProtaStructure 2025 was the castellated beams. As you know, they are a special type of beams that you just cut a hot rod profile or a built-up profile and put them on top of each other so that you have an increased height, you have less material, and you have more capacity. That's the advantage of castellated beams. How you define castellated beams in ProtaStructure is that they are nothing but regular frames, and they have castellated properties defined on top of them. You can open a circular opening. That means you can create a cellular beam, or you can open hexagonal openings. You can specify spacings, start offset, end offset, width and height. And you can even close some of the holes for, prohibited zones or plumbing, etc. Anyway, so you can define the castellated properties using the castellated tab in the frame value. What I want to focus here is the design of these members. They have some advantages in terms of the capacity and the less material, but they also they have to be checked against additional failure mechanisms like a wear and tear check or horizontal horizontal shear check, Virendal checks, and horizontal shear checks, vertical shear checks, and web post buckling checks. Because when we open up some, when we create some openings, we will have two T sections at the top and bottom, and the entire castellated beam will start to act like a Virendal truss. So that means we have to check those T sections, and also the intermediate web portions will be vulnerable against buckling, so they have to be checked as well. So there are additional failure mechanisms that needs to be checked. So these are all done here. And in the detailed report, of course, you can see all the details as well. So okay, it was a very quick story about the castellated beams. And I want to talk about a very interesting topic, actually, which is the orthotropic slabs. In ProtaStructure, we have a slab type called one-way slabs. So when you open up properties of a slab, we have a type at the beginning, which is a one-way slab type. So, and when you select this type, you specify an angle that's the direction of the one-way slab. Okay, anyway, so in the previous version, when you define a slab like this, when you define a one-way slab, we weren't meshing it. We weren't including that slab in the finite element mesh, because in the finite element mesh, when you mesh a slab, that means it will be acting in and distributing loads in two different directions. So and when you mesh it, it's against the one-way slab assumption. So that was why we weren't meshing those slabs. But now with the new version, we introduced the orthotropic material properties. So now we can mesh these slabs. And what I want to explain is actually this. So if you look at the analysis model, these are one-way slabs, and these are meshed. But let's check, maybe I want to get rid of the story 1. I want to focus on story 2. Okay, so I have, and this is a one-way slab working in this direction. So in X1, we have a sagging moment calculated here. In the other direction, let's check the slab diagram. We have a zero moment because it has an orthotropic material property. What I mean by orthotropic, in the major direction, the slab shells are using their full Young's modulus. And in the other direction, they are not using any Young's modulus. The Young's modulus value is significantly reduced in the other direction, so that they are acting like a one-way slab. And also there is another property here. If you check once again, in the load section, you can say that moments are released at the supported edge. So you want to model a one-way slab, but also you don't want to transfer moments at the edges. So you can do that. It's called knife edge support. So if you want to have a pin connection at the slab edges, you can just say that moment release at the supported edge. And moreover, if you want to disconnect the unsupported edges, you can also disconnect them. So in the analysis, they will act as if they are not touching the the supports. So let me show you here maybe. So in the members, if you open up the node labels, okay, you will see that in fact there are two nodes, two series of coincident nodes on top of each other, but we are connecting them with constraints. But in fact, the slabs are not connecting to the beams here. And also here, we also have coincidence points. This slab is not connecting to, I mean, connected, but not transferring any moment to the other joint. They are connected with a constraint, equal constraint. Anyway, so why this feature may be important? Because if you want to model some prefabricated slabs, one-way slabs, and if you want to include them in the mesh, you can use this feature, obviously. Okay. Another important addition was the stepped foundations. Let me show it here, maybe. So this is a typical model for you have elevator pits here and step foundation. So how you define them is actually quite easy. All you have to do is set the relative level of the slab here, relative level, and include that relative level in the analysis by saying that apply Z to analysis model. Okay, that's very easy. Also, for this slab, maybe we have minus 380, and I want to include them in the analysis model. And you can model, for example, this slab, this shear wall here is a basement wall, and it is defined in the Storey 1. When you look at the wall properties, you will see that the top is dropped by 5 meters, and the bottom is dropped by 2 meters. And for this wall, let's check the properties. The top is not dropped. Top is sitting at the Storey 2 level. Storey 1 level, and the bottom is dropped. Bottom edge is dropped by 380 centimeters. You can, by this way, you can easily define the step foundations with different elevations. Okay, since, for example, these walls, these ones, this one here, only this portion, and these walls will be under this will be supporting the soil. We have to define some soil loads on these walls. So how to do that? Of course we have the load editor here. So let's see this. Let's open the transparency to see it's maybe better, and change the load case in HX load case, which is the soil load in X direction. I can define distributed loads or function loads to the walls like this. And in the other direction, you can apply loads, uniform loads or function loads on the wall surfaces. So that's how you apply the soil loads on the walls. I will not go into the details of how to do that, but you can easily do that using the loading editor. And finally, maybe we can check the analysis model. Let's check the building analysis model. Okay, first of all, you can see that all the slabs and walls are meshed in a compatible manner, and the elevation difference is reflected in the analysis model. So this is how you can see what's going on with the structure, and also you have the option to separately analyze the foundation. This is a specific model that we create for foundation analysis. If you don't want to analyze the foundation with the building, you can isolate the foundation, transfer the reactions from the building to the foundation, and analyze the foundation separately. And this is that model. And this is also, in this model, you can see the elevation differences as well. Anyway, that's, I think, enough for step foundations. I have more topics, unfortunately. I know you are getting tired, maybe. We almost spent 90 minutes, right? Okay, I think I don't have much topics to discuss. Maybe I can be a bit quicker. Okay. I think this is important because this is something very, I mean, that we didn't release in the first version of 2025, but we released this feature with the first maintenance pack of 2025. So if you downloaded the latest update, you will have this feature. We didn't have it with the first release. First of all, you can now insert column drops in the foundation level. In the previous versions, you couldn't do that in the foundation. You could only insert the column drops at the story levels. Now you can insert the drops in the foundation. This was introduced in 2024, the previous version. Okay, but one important thing is, let's check the finite element analysis. Sorry, analysis model. What I want to check is the under the envelope max. Maybe I want to open up the contours and maybe envelope, or let's say, okay. Max. Anyway, for the first combination, let's say we have the out of plane shear contours like this. The V13 is the out of plane shear forces in local axis, I mean, parallel to the local axis 1 surface. And the V23 is the out of plane shear forces parallel to the local axis 2 face of the shell. It's about sign convention, but the subscript 3 here is important. That means the force is in the local axis 3 direction. Anyway, so we have out of plane shear forces acting on the foundation like this. First of all, in the latest maintenance update, we will always include the column sections in the finite element mesh. If you have a flat slab or a raft foundation, you will always have these outlines cropped from the mesh. Okay, because that will give more, better results in the punching check. That's what I will come. Okay, just don't remember this picture here. Okay, let's close this one. Also, maybe what I can show is, let's close this, and also let's close the displacements. And maybe here I can open thickness. So, okay, what's happening? Okay, so here you see this the shells in the vicinity of the column have 55 centimeter thickness, while the other shells are 35 centimeter thick. That means we included the column drop in the finite element model as well. Anyway, so let's close this. And in the visual interrogation, what I want to do, FE contours, I want to open up the, okay, that's fine. These are the out of plane V1-3 forces in the first combination. So you can see them at the same time. What I want to do now is perform the punching check. Let's calculate. And this punching check is now can be done according to ACI code and Indian codes, and also as well as Philippines, Indonesia, Colombia, Peru, etc. So this is new in the latest update. Okay, this wasn't in the, again important, this wasn't in the original 2025 release in August, but 1 month ago we released the latest update. So this is in the update. So you can now perform the punching check according to ACI and the similar codes in India. And this punching check is based on the finite element results. What we do, we collect the most critical out of plane shear along the perimeter, and we use that value in the punching check. Okay, the details are here. So in codes there are different formulas, and also if the punching stress, the tau, is greater than the cracking stress, you have to calculate some reinforcement, etc. And also you have to check the consecutive punching perimeters until you satisfy the conditions. Anyway, there are some details on that. Let's close it. As you see, we also show the punching perimeters here in the blue, the green color. That means this column is sufficient in terms of punching, but this column isn't, etc. So this was the thing that I wanted to mention. So the punching checks can now be done according to India and American codes, and it is depending on the finite element results. And also one important takeaway is that if you have a flat slab or raft foundation, the column sections are always included in the finite element mesh. Okay. We can maybe continue with the same model. Open up the model here. Okay, let's see. Close the thicknesses, results, contours. Maybe I can open up the bottom reinforcement contours in the under the vertical load case. We have now an option, show minimum AS in rebar contours. So if you have a rebar contour, ProtaStructure by default will always show you the required area of reinforcement, area, and you know that you are aware that that required area may be under the minimum specified by the code. So here, for example, the rebar contour is showing the required area, and that required amount can be under the minimum amount. But we put a new option here, show minimum AS. So when you press that, pay attention to the legend here. Let's increase the size of the legends. Okay. You see the minimum starts with 0, and maximum is 31 centimeters square per meter. So when I click on the show minimum AS, now the minimum starts with 5.4, and the contour is adjusted accordingly. So in this way, maybe it will help you. It will definitely help you to identify where you need the minimum and where the minimum is not sufficient. That's a very practical way of seeing what's happening in the foundation or in the flat slab or in the floor system above. Anyway, so this was a very small but very effective feature as well. Okay, one last maybe demonstration can be on the assessment part. As you know, ProtaStructure is also very powerful in terms of existing building assessment and performance-based design. So we have a lot of techniques in the software, like single mode pushover analysis, multi-mode pushover analysis. By the way, multi-mode pushover analysis is a new feature in the ProtaStructure 2025. And we also have nonlinear time history analysis. We automatically calculate all the nonlinearities, all the material nonlinearities, and we can communicate these nonlinearities to the OpenSees, and we perform all the analysis, all the nonlinear analysis in the OpenSees, and we collect the results back, and we them to a post-processing, and we create the assessment report. I can talk about this assessment maybe in another webinar because it's a very detailed topic by itself. But what I want to talk about here is the visualization part. What we did in ProtaStructure 2025 is we can now visualize the assessment results. If you perform, for example, a nonlinear time history analysis, let's see that. Okay, maybe I could show you the building, but anyway, you will see that. It's taking a bit time because it's not easy to buffer all the time history results because there are thousands of time step results in separate degrees of freedom. So, okay, now we have the analysis model. It's a moderate building. Let's switch to the perspective view. Okay. So in the results, as you see at the right side, we have the earthquake ground motion record that we performed the analysis. And let's hit the animation. Okay. Okay, let's stop the animation. And I want to scale this to 10 so you can see it better. And let's start the animation once more. Now, as you see, as we progress on the earthquake record, and we animate the shaking of earthquake displacements on the building, and at the same time, the plastic hinges started to form on the critical sections. So now we have blue color. That means it exits the life safety. Now we have exiting. The yellow ones are between the collapse, before the collapse prevention, between the life safety and the collapse prevention. And as the earthquake, there are no collapsing members actually, but there are members, the yellow ones are between the life safety and the collapse prevention. So you can see which members are getting damaged at which time step of the earthquake animation. So let's see once again. So this is actually quite an important feature because previously you couldn't see this in the software. This is fantastic. I mean, this is a very important addition to the assessment part of the software. By the way, I can say that we are currently working on implementing the US codes and Euro codes assessment criteria in the software. So currently, when you perform an assessment, you get an assessment report at the end, because the assessment itself is not sufficient. You have to go member by member and see if those members are satisfying the performance limits or not. So that's what ProtaStructure does actually. We prepare a report at the end, but that report currently only is compliant to the Turkish code. But what we are doing at the moment, we are developing the US codes and Euro codes. And next version, hopefully, you will get these at your hands. Okay, let's close this. And we have the same thing actually. Let's see the building, by the way. We have the same thing for the pushover analysis. Now, instead of this time a time history curve, a time history signal, you have now a pushover curve. As you progress on the pushover curve, you'll see how the building is getting damaged. Okay. Let's see how I will process. I think we are getting close to the finish. So let's continue with the presentation. So I already mentioned about the Eurocode features that we have, about the seismic design. We also have a non-seismic purlin design. We have, I didn't show you the space truss in the live demonstration, but we have the new space truss macro here. We can specify the parameters and create a space truss on top of any opening, any span. So let's see. Okay, and also in this version, we developed the copy special functionality, so you can select a bunch of members and copy special. In this command, you only need to enter the amount of distance you want to copy and number of instances, and it will be easily copied. So again, maybe you want to copy them in the y direction, minus 2.5 meters, and that's done. And you can use this copy and move special comments very easily. And also we improved the mirror commands, because we may have truss members or purlin members, girt members, brace members. So we improved the mirror commands so that you can mirror all member types accurately and easily. So here you see how you can do it with respect to any symmetry axis. So it's also interactive. You can multiply or replicate your model very easily. And we have a match member properties command. It's like a Microsoft Word format painter. If you have a source member and you want to apply the certain features, certain properties of that member to other members, you can use the match properties command now. If you have a cladding, you can now easily apply the loads on the cladding while inserting it. You don't have to go into the loading editor to apply the loads. You can just specify the self-weight, dead load, live loads on the cladding itself, and ProtaStructure will automatically apply the distributed loads on the cladding. Let's progress, move it forward. So when you go to the load editor, you will see that all the loads will be automatically applied on the cladding already. Okay, and regarding ProtaSteel, we have new features. The most prominent, most important new feature in ProtaSteel is the idea statica in export. If you have connection in ProtaSteel, you can now export them to idea statica for CBFEM analysis. This is an important addition. I believe you will benefit from it a lot. All you have to do is run the IDEA Statica checkbot inside ProtaSteel and select the connections, and they are communicated to IDEA Statica. Another important feature is the partial model updates, because between ProtaStructure and ProtaSteel there is a one-way data communication. Okay, suppose that you transferred the model to ProtaSteel and you worked on it, you inserted some connections, you adjusted and fine-tuned the steel model for fabrication. And when the ProtaStructure model changes, you can update the model from ProtaStructure. You can send the updates to the ProtaSteel, so the members are updated. But in the previous versions, we were always attempting to update the entire model, but now you can only send some of the members. If you changed a specific member, for example, you can only communicate that member to ProtaSteel, and only that member will be updated. That's a very huge increase in productivity. And we have a new stiffened base plate connection. Actually, this type of connection is usually used for intense loading scenarios. So you can use it, for example, for cruciform columns, etc. So this is a new type of connection. You can now apply the end plate connection at the ends of the curved beams. The approach angles of the curved beams must be near to the 90-degree perpendicular. And we have the extended end plate connection with additional tension bolts. In fact, extended end plate is one of the pre-qualified connections that you can use in ProtaSteel. So now you can also introduce additional bolts at the flanges. Okay, so these were the outstanding items that I wanted to talk about in ProtaStructure 2025. Actually, there are a lot more in this sense, but we don't have enough time to discuss it. Actually, we did a launch webinar, remember, back in August. So in that launch webinar, we were discussing all the small details as well. But in this webinar, I wanted to personally talk to you and show you the features in a live manner. So I was just using the software, showing you the features and talking you about the things that I think are most important. So I hope you liked what you see. Of course, there is no limits in discussing the details. We can sit here for hours and discuss each and every engineering detail here, which there are a lot in ProtaStructure. So if you have any questions, please ask in the questions panel or send us email. And what I want to say that please take a look at always or subscribe to the knowledge base and community forums, because we are releasing the release notes. We are publishing the release notes in a knowledge base. So take a look at the release notes. We have a huge deal of details in 2024 version and also 2025 version. So you can see those details in the knowledge base. And also, don't forget to visit the Help Center. You can get the self-service support there 24/7. You can create tickets in the Help Center. You can join the community, discuss. Also, subscribe to the YouTube channel. This is not about collecting subscribers. This is about us publishing the training videos, because all the webinars and all the training videos are published in our YouTube channel. And if you subscribe to our YouTube channel, you will be the first to be notified about those. And also follow us on our social media accounts. And you can send us email on global sales if you have questions about any sales. or if you have any questions about the support, you can send us email on globalsupport@protasoftware.com. Thank you so much for your time, and this concludes my presentation. I hope you enjoyed what you see. We have a lot of features in ProtaStructure 2025. As I said, we are already working on the maintenance updates. We have released one of them 1 month ago. We will release another one in the upcoming weeks. And we are also working on the next major version with a lot of new features. When the roadmap is finalized, we will share it with the partners and or resellers. And I can say that we will have exciting new features. Anyway, thank you all for participating. Thank you for your time. It was a pleasure for me conducting this webinar. I hope to see you next time in the other gatherings. Take care, stay safe. Thank you.